question. Here I'm taking good enough time on each question because my purpose here is not to solve a lot of questions. My purpose is to give you approach. Normal at the point y square is equal to 8x, where abscissa is equal to ordinate, will meet the parabola again at a point. Again, if we solve this question using the usual method, that question will take a lot of time. Okay, so here we are going to use some results, and what I will do for your convenience, I'll try to mention all the results that are used in this question. In fact, I will try to recap all the results related to normal of the parabola. Let's start. So we have here y square is equal to 8x. First thing you can do is compare it with y square is equal to 4ax, and you will get the value of a is equal to 2. Okay. So just like we have results for tangents of the parabola, we have results for the normal also. What are those results? So first result, there are many, but the results which are absolutely necessary to remember. There are three results. First result is equation of normal. Equation of normal at a t square comma 280. Please be mindful of this a t square comma 280. It reappears again and again in questions. Okay. So equation of normal at a t square comma 280 is a t cube plus t into 2a minus x minus y is equal to 0. Now this equation of tangent, what do I mean by this? Listen, equation of normal is a equation of a line, and equation of line has x and y. Okay. Equation of a line is a linear equation of x and y, and t is just a parameter. What I mean here, that at any point on the parabola, any point can be given or found out by using or by giving the value of this parameter t. Once I substitute the parameter t, I will get a point. So how will I get the equation of normal at that point? So you can just remember the standard result. This is equation of normal. Second result that you must remember, okay, I'm not saying you should remember, you must remember if you want to be a candidate of JEE, means in advance. So second result is if normal at t meets the curve again, at t dash, then t dash is equal to minus t minus 2 by t. I'll try to give a pictorial explanation for all these results. Okay, that is second. And the third result that you must remember is point of intersection of normals at t1 and t2. Please remember t1 and t2 are parameters. By t1 I mean the point a t1 square comma 2a t1 and a t2 square comma 2a t2. Okay. So the point of intersection of normals at t1 and t2 is 2a plus a into t1 square plus t2 square plus t1 t2. Then, and please remember, this is just the x coordinate. Okay, this entire term is only the x coordinate. Y coordinate is minus a t1 minus a t1 t2 into t1 plus t2. Okay, so this entire term is the x coordinate and this entire term is the y coordinate. You might be thinking, how are we able to find these points? So it is simple. You take the parabola. Let's say this is our parabola. Y square is equal to 4ax. We have assumed one point P, a t1 square comma 2a t1, and another point Q, a t2 square comma 2a t2. If you remember, by using t is equal to 0, we can find the equation of tangents. So you can find equation of tangent at P, you can find equation of tangent at Q, and you can also find the point of intersection of those tangents, the previous result that we have discussed. Once you have equation of tangent, you can have slope of tangent. And we know normal is just a line which is perpendicular to tangent at that point. So we can use slope of tangent to find the slope of normal. So slope of normal is nothing but -1 by slope of tangent. From there, we can find the equation of normal, this normal, this normal, and their point of intersection S. So after doing all this work, the point of intersection came out to be this. Okay. Again, this normal will be, I'm using a different diagram. Let's say at point P, a normal is drawn, at square comma 280. Then we resolved at point Q to find the point of intersection of normal with the parabola. We can solve the normal and parabola simultaneously. Then you will get a t dash square comma 2a t dash. So that is how the results are derived. Once results are derived using the manual way, then they are directly used to save the time in the exam. Though in the question there is only the normal meets the parabola again, I just revised all three concepts so that you can solve any questions related to normal in future. So normal at parabola, this may where abscissa is equal to ordinate. I hope you know. Abscissa is the x coordinate and ordinate is the y coordinate. So you have to find the point where normal abscissa, there is a point on this parabola where abscissa is equal to ordinate, means x is equal to y. So you have to draw a normal at that point, and that normal at that point is meeting the parabola again. So you have to find the point where the parabola is meeting with the normal the second time. Okay. So the equation of parabola is y square is equal to 8x, and the point where x and y both are equal. So what we can do, we can substitute y is equal to x or x is equal to y. So x square is equal to 8x. So from here, please remember, you cannot cancel x from both sides. Never cancel the common factor. So x square minus 8x is equal to 0. Now take x common. You will have x minus 8 is equal to 0. One term will come out to be x is equal to 0 and another is x is equal to 8. So it seems to me they are not talking about x is equal to 0. Why? So x is equal to 0 will give you y also equals to 0. And normal at x is equal to 0 and y is equal to 0. What is x is equal to 0 and y is equal to 0 for this parabola? 0, 0 is just vertex of this parabola, and normal at vertex is the axis itself. Okay. And axis never meets the parabola again. Axis is the normal which never meets the parabola again. Okay. So they are talking about the point x is equal to 8. So y will also be 8. Now compare this with at square comma 280. So for y square is equal to 8x, a will come out to be 2. So this is 2t square comma 4t, and here you can see the value of t is simply 2. The value of t is 2, and always find out the value of t using the non-square term. Okay, because if I equate t square with 4, t will come out to be plus minus 2, so there will be a confusion. So rather always compare the non-square term. Okay, we know from the second result, if normal at t meets the curve again at t dash, then t dash is minus t minus 2 by t. So we can simply use the result directly. T dash is minus t minus 2 by t. So it will be minus 2 minus 2 by 2 or minus 3. So this t dash is minus 3, and you have to find parametric point at square comma 280. So substitute a is equal to 2 and t is equal to minus 3. Your result will come out to be 2 into minus 3 square is 18, and 2 into 2, 4 into minus 3 is minus 12. So 18 comma minus 12. Let's see. 18 comma minus 12. Option D. So three results. First result is equation of normal at at square comma 280. That is a t cube plus t into 2a minus x minus y is equal to 0. Second result is if normal drawn at point t meets the curve again at t dash, then t dash is minus t minus 2 by t. And the third result is that point of intersection of normals at T1 and T2 is 2a plus a into T1 square plus T2 square plus T1 T2 minus a into T1 T2 into T1 plus T2. This T2 looks like K. Let me correct it. It's not K2. K is not there in the question. T1 plus T2. Okay. I hope you understood the question. Let's move on to the next question. If the tangents to parabola y square